Hi, I'm Amy Bass, and for my experiment, I decided to do the cup in the corn experiment, and my husband Brad is going to be helping me today. Brad, I would like for you to take the cardboard piece of paper and place it over the cup. Now I would like for you to take the corn and put it on top of the paper. Okay? Now, how do you think we can get that corn inside the cup without removing the paper?
I could tilt the paper.
Okay. How else do you think we could get it in there? Without lifting the card up.
Without lifting.
Mm-hmm.
I could pull it.
Okay.
Pull it slow. Pull it fast.
Pull it fast, okay. Now, whenever you pull the paper fast, why did the corn drop in the cup when it was pulled away?
Not sure.
Okay, well, let's try it again. And why do you think the corn fell into the cup?
Well, the paper's kind of slick. Not a lot of friction on it.
Okay.
And I was applying the force to the card and not the corn.
Okay.
So I moved the card, but since there was not much friction on the surface, the corn stayed in the same spot.
Okay.
Until gravity took over.
Okay. And that's what we want to talk about today is inertia. Now, let's see what happens if you move the card slowly. What happened?
Stays on the card.
And why do you think it stayed on the card?
Not sure. I didn't have enough force on the card to pull it. The corn stayed with the card.
Okay. Well, that is called inertia, and inertia is also called the tendency to stay at rest. So, do you think when you move the card slowly away from the cup, did the corn stay at rest?
Stay at rest on the card.
On the card. Okay. And then what happened when you pulled the card away quickly?
It stayed right here.
Okay. And what effect is that? Why did it stay there?
Inertia.
Inertia. Okay. Now, I want you to take this same concept and think about how we can apply this in daily life. Think about how we use inertia in daily life.
When you get on the subway and you're standing still and it's fixing to take off, you better hold on.
And why is that?
Because you'll stay still. You'll stay as the train leaves and you're still standing. If you don't hold on, you're going to try to stay in that spot while the train goes forward and you'll fall back unless you're holding on.
Okay, good. And that's exactly what inertia is all about, what we're learning about today. That the inertia of an object is directly proportional to its mass. Good job. You did an excellent job.